what's going on out where you are right now?
Where'd my glasses go?
Guys, it is hot out here, but everybody's out here having a great time. We still have glasses, the Eclipse glasses left, so you could still have time to head out. And when we're not looking up with the glasses, we're in these big telescopes. Kira here has been checking out the sun. What are you seeing in this big telescope?
It's the sun, but it's shaped more like the moon, more like a crescent moon, and I can even see the sunspots.
You see sunspots. How awesome is that?
Really awesome.
Science is just oozing out of here. We're having such a great time. We've got more than one telescope. We've got plenty of Eclipse glasses, and it's telescopes like these. Now, not only Kira and I are using, physicists across the country are using them right now to gather data on the sun's corona, and our own Springfield scientists are part of the project.
It's here.
I'm getting goosebumps just thinking about it right now, honestly. And I do it just about every time because it's such a spectacular thing.
Once in a lifetime. That's how many are explaining the thought of getting to witness the total solar eclipse. But what is it? The moon will move between the Earth and the sun, casting a shadow on the Earth's surface. While the moon is 400 times smaller than the sun, it will look like the moon blocks out the sun completely, as if they are the same size. That's because the sun is also 400 times farther away, a coincidence not like any other in the solar system, even with the moon making a pass in this same spot every 18 months.
What makes this so rare and complicated is that the sun, the Earth, and the moon all have their own separate orbits, tilts, and rotations, and they all need to line up so perfectly to get this shadow. Essentially, this little ball needs to make a shadow on this basketball or the Earth over your house, and the peak lasts for just 2 minutes.
It's only about a 100-mile circle, and that 100 miles is really small compared to the size of the Earth. So it could be almost anywhere on the surface of the Earth. The chance it'll fall right where you live is pretty small.
While the eclipse will do many cool things like blacken out our skies and drop temperatures by up to 20 degrees in just minutes, scientists are eagerly waiting on the sidelines with telescopes ready to capture new data, some unlike we've ever seen before.
We've got a solar filter on the top of this telescope here, which on eclipse day we're not going to wind up needing. We'll have the brightness of the sun come through the telescope. There's a camera here at the bottom with a GPS tracking device, and then these images come through this laptop, and on eclipse day we'll be able to see the corona of the sun.
Drury University physics professors Dr. Bruce Callan and Dr. Gregory Ojokongas are just one of 68 teams across the U.S. to gather data on the path of totality. The goal is to take pictures of the sun's corona, the outer atmosphere of the sun. It's hard to see this on a regular day because the sun is so bright.
But when the moon is in place blocking out all of the ordinary sunlight, then this corona becomes visible. And our job is to photograph that corona for 2 or 2.5 minutes during the totality phase of the eclipse.
Both satellites and astronauts have been used in space to try to collect this data.
It helps us understand how the sun works.
But being able to observe the corona from the ground during the eclipse will help provide the best we've ever had.
If we understand our life-giving star better, then that's a healthy thing for the planet.
Both Drury professors and their students have been practicing nailing down the observation steps all summer, so when it's game time, they're ready to go.
It is phenomenal, you know, a mind-blowing experience.
Back here at the Missouri Institute of Natural Science, we're getting close. We're getting close. You can start to see a little bit of a crescent, but you've got to use those glasses, and we have plenty of them left here with many telescopes. Now, coming up next, our Daniel Shedd is at the zoo to see how the animals are going to react to the brief darkness. That's next.